The first thing that I'm going to install on my cluster to make my life easier will be about DNS. It's something called ExternalDNS, and what it does is that it creates DNS records from Kubernetes resources, specifically from services and ingresses. For instance, right now on my cluster, I have this handful of services, and let's look at the load balancer services in particular. They have these external IPs here, and right now, if I want to connect to this one, web, so that's the Nginx one, I have to enter this IP address in my browser, and that gives me welcome to Nginx. All right, well, instead of entering an IP address, I would like to put something like nginx.whatever.domain.com, you know. So to do that, I will need a couple of things. I will obviously need a domain name, and I need to be able to configure that domain through an API, because external DNS will use that API to create the records. So as of now, external DNS supports a bunch of providers here, and that includes Linode DNS right there. So that's what I'm going to use. Now, without giving you a full course on DNS, we need to know that there is a difference between the place where we buy the domain and then the place where we host the domain. Example, here I bought my domain from Gandhi because that's where I buy all my domains. But since Gandhi is not supported by external DNS, they have an API, but fortunately the API is not integrated with external DNS yet. So what I did is that I then hosted the domain with Linode. So first step, buy the domain. Step two, in Linode, I go to domains, I do create domains, I put the name of the domain I just bought, like cloudnative.party in my case, and then here we can see, okay, cloudnative.party. And there is one thing that I recommend that you do, it's to change that default TTL here. You can see here that I've reduced it to 5 minutes, so edit default TTL, and I basically changed that to the lowest value I could. So what is this TTL about, and why do I want to reduce it? The TTL is the time to live of the DNS records. This indicates how long the records can be cached by DNS servers all around. And maybe you have heard names like DNS propagation delay, and also the fact that caching is a hard problem in computer science, and perhaps although that famous networking joke, you know, about DNS, which is in 3 steps, like first one, oh, it can't possibly be DNS. Step 2, well, maybe it's DNS. And step 3, it was DNS, because there are so many weird problems caused by DNS. And sometimes it's caused by caching. The symptoms are like this, like you make your DNS change and then you're like, I don't understand. I make the change, I can see the change here, you know, like in my records, I can see the new IP address, and yet when I try to connect, it's still going to the old address. What's going on? And if my neighbor tries the same thing, it works for them, but not for me. Like, what's going on? Very often it will be because of caching. Not always, but it's a pretty common cause. So here, to try to mitigate that a little bit, I changed that TTL to put it as low as possible. So I don't know for sure what was the default here. I don't remember if it's a couple of hours or maybe even 12 hours, but either way, that's too long when we're doing little testing like this. So 5 minutes, that means that when we add or when we change a DNS record, if we're pretty unlucky, we are going to still see the old record for 5 minutes, but after 5 minutes, we should get the new value and we don't have to wait, you know, like, 12 hours before the cache expires, because that would be really annoying. Okay, so step 1, as I was saying, we buy the domain, then we get the domain on Linode. When you put the domain on Linode, it's going to give you the list of named servers here, ns12345.linode.com. And then I go back to my registrar, the place where I bought the domain, and I go to name servers, and then I make sure that I have the same list of name servers here. And once you've done that, then your domain will be ready to be used with external DNS. All right, so now how do we deploy external DNS? So they have a pretty good tutorial for Linode. So we go there, and basically what it tells us is, hey, here is a bunch of YAML. So just get that YAML, change a few things, like put your Linode API key here, apply that YAML, and you're good. So remember when we talked about Helm, I was precisely explaining, I don't want to do that. I don't want to get some YAML and manually tweak that YAML. I would like to do something like Helm install external DNS and -- token, whatever, because that's going to be a little bit more repeatable, a little bit nicer than having this copy-pasted YAML thing here. All right, so how are we going to do that? Well, we will need to find a Helm chart for external DNS. So we can go to the artifact hub, and here if we search like external DNS, well, guess what? There is an external DNS chart made by Bitnami. That name came up earlier. I mentioned like Bitnami does a lot of really good Helm charts, so we're going to see them a lot. And we're going to use their chart to deploy external DNS on our cluster. All right, so now, when we will install Helm charts on the cluster, remember I like things to be boring and predictable. So when I install the chart like foo, I'm going to put it in its own namespace that I will call foo. And then when I install the release, you know, like when we install something with Helm, we have to give it a name. I'm going to also name it foo. So there's going to be like Helm install foo in namespace foo and call it foo. So that way it's easier to remember where things are and how we name them, etc., etc. Another thing, earlier I showed you how to install things with Helm using Helm install. That makes sense. We install things with Helm install. I'm going to show you a slightly different technique now. Helm upgrade -- install. What's this about? So there is a word that we often use in computer science. It's idempotent. So what is idempotent? Idempotent means it's an action that you can do multiple times, and whether you do it 1 time or 10 times, you get the same result. You know, it's a little bit like an insert or update. If you do an insert, if the thing is already there, you end up inserting it twice. If you do an update and the thing doesn't exist, well, it doesn't work. So same idea here. If you do Helm install multiple times, the first time works and the next times it's like, nope, that already exists, or you end up with duplicate installs. If you do Helm upgrade, but the thing does not exist, it will fail. Now when you do Helm upgrade -- install, that means upgrade the thing, and if the thing does not exist, install it. So that's what we want. This is just like using kubectl apply. As you might remember, when we do kubectl apply, it's going to create resources, but if the resources already exist, it's going to update these resources to match what we have in the YAML. So we're going to use Helm upgrade -- install all over the place now. And we are also going to use flags -- namespace to indicate in which namespace we want to put the thing, and -- create namespace, which, as you can guess, is going to create the namespace when needed. So what will that look like? Well, like this. Step 1, we need to add the Bitnami repo. Okay, when I do that, guess what? I already have the Bitnami repo on my machine, so it's just going to tell me that this already exists. But when you do it, it will effectively add the repo. Next step, we need a Linode DNS API token. So let's get one. So I go to Linode here, and I need to go on the top right corner there, API tokens, and I say create personal access token. I'm going to call that ExternalDNS, expire, yeah, in a month, whatever. And I'm going to select read-write access for domains, create token, and there we go, we have a wonderful token here. So I'm going to copy paste that. I'm going to put that in like Linode DNS token so that I have it for later just in case. And yes, in case you're wondering, if you get that token now, you can use it to create DNS records in my cloudnative.party domain name, unless I revoke the token after recording all these videos. Will I do it? Will I forget? Surprise, only one way to find out. Okay, so we have a token. Awesome. Now, how do we install external DNS? So, first, I suggest to put that in an environment variable. So Linode API token equal this. Awesome. And then the Helm upgrade install, etc., etc., etc. So we could either type that very long command, or I'm actually going to copy paste that. But before I run it, I'm going to go through the arguments one more time so that we remember what everything does. So upgrade -- install. So that means if it already exists, update it, upgrade it. But if it doesn't, install it. We are going to call that release external DNS. It's using the external DNS chart in the Bitnami repo that we just added before. We put that in the external DNS namespace. We create that namespace if it doesn't exist. And then we give a couple of parameters. We indicate which provider to use and the API token to use for this provider. So I do that. It's going to install external DNS. And now, okay, very conveniently, it suggests, hey, if you want to check that everything works fine, you can actually run that command. And I'm like, well, that sounds like a very good idea. So I see that I have a pod running here, but it's not ready yet. So it means it's probably still starting. And okay, now it says it's running. So now we could, take a look at the logs. So a couple of options to look at the logs. I can do kubectl logs in namespace external DNS. And here, I just used completion to get the pod name. And that works because there is only one pod in that namespace. So obviously kubectl knows which one I'm talking about. There we go. So there is a bunch of output telling me that everything started and seems to be fine. Well, I guess we should give this a try now. So how do we test that? Well, for services, what we do is that we use an annotation. We need to tell external DNS, hey, you see that service here? I would like that service to be exposed with that specific name. So here, for instance, web, I would like that to be exposed with nginx.cloudnative.party. Of course, in all my examples, I will be using cloudnative.party, but you should replace that with your own domain, right? Okay, so let's try this. kubectl annotate service, and the annotation is this. So external DNS alpha Kubernetes IO hostname, and then the name that we want to use. So let's say nginx.cloudnative.party. Whoops, what did I forget? Oh, I forgot to put the name of the service. I need to tell which service I'm annotating, and that's web. Okay, annotated, perfect. Now, if I take a look at the external DNS logs, bingo, you can see that almost instantly it said creating record. So we have record nginx in zone cloudnative.party, and we also have a txt record that has been created. We're going to look at that as well. All right, so now if I try, let's say, curl nginx.cloudnative.party, most likely that won't work. See, could not resolve host nginx.cloudnative.party. This is because of DNS update delay, this whole caching business. Even though the record was added in the API, it might take a minute before it's actually visible on the DNS servers. So, meanwhile, we can go and have a little look here in the domain on the web interface. I can see that, yep, I got my nginx record right there, and we can take a look at that txt record, and that txt record is actually really useful. See that thing here like heritage equal blah blah blah, etc. This is something used by external DNS to keep track of ownership of records. This is a way for external DNS to remember, so to speak, hey, this is one of mine. That way, if you have a zone where you have a mix between records managed by external DNS and manual records, external DNS will know to not touch the records that it did not create. All right. So, well, this is one of these cases where we might have to wait a few minutes before the DNS record becomes available. So I suggest that you take 5 minutes, to grab a coffee or stretch a little bit, whatever, look at the scene of nature, because supposedly that helps the brain to relax, and come back after to check if our DNS record works correctly. So about 5 minutes later, our record should be available. And so now, lo and behold, if I go to nginx.cloudnative.party, I get welcome to Nginx. Awesome. Now for even more fun, what we can do is try the same thing with some other services that we have here. For instance, I could do that. So that was my annotation, right? Now what happens if I try to add juice.cloudnative.party for like my public juice shop, this one, which is using a load balancer, right? And for even more fun, we are going to try to annotate a node port service and see what happens in that case. And so let's try the other one. So the other one is called my juice shop here. And I'm going to call it like node juice, for instance, .cloudnative.party. So I do these annotations, and then I have basically two options. Either I'm like, okay, let's just, go again for a walk or a coffee or whatever for 5 minutes to wait for the DNS records to show up. Or I can also be like, hey, let's just look on the Linode interface so that we see what happened. So I'm going to head there, reload that page, and have a look. And see, that's pretty interesting. So for the other one, like juice, obviously we have a record pointing, like juice pointing to the IP address of that service. But look at what happened for that one, node juice. Node juice, we have 3 IP addresses, 3 A records. What is this about? And maybe you're guessing already because it's a node port and I made sure to call it like node juice. So perhaps you're guessing that these IP addresses here are actually the IP addresses of my nodes, and I'm going to check that. Yep, fair enough. You can see that the external IPs of my nodes are like 198.162.172, and yep, 198.162.172. So this is a kind of little bonus in external DNS when we add this annotation on a node port service, it's going to create a record that will point to all the nodes of the cluster. There are some situations where that could be pretty useful. So I'm going to wait, like again, a few minutes until the records are available, and then we are going to try them. A few minutes later, after my records get available, I can try to connect to juice.cloudnative.party, and then, surprise, it doesn't work. And I'm like, wait a minute, okay, DNS seems to be fine, because if it were a DNS problem at this point, I would get something different. If I try non-existent.cloudnative.party, we're going to have, okay, it looks like it's a different error message, right? That one basically means DNS did not resolve, and that one means DNS did resolve, but then we could not connect. Why? Well, because if we take a closer look at our services right there, get SVC, we can see that this one is not listening on port 80, but on port 3000. So we would need to put 3000 here to be able to connect, and remove the S in HTTPS here, and there we go. We're connecting to this instance of the app. So of course, if we wanted to have something nicer here, we would need to edit that service here so that the front port is 80 instead of 3000. And now to go, a little bit farther and keep exploring things, let's see what happens if I try to connect to nodejuice.cloudnative.party. That doesn't work. It's like, okay, I know this. I need to put port 3000 and remove the S in HTTPS, and that still doesn't work. And I'm like, okay, what is this about? Well, again, let's take a closer look at our services here. And this is a node port, and the node port is not listening on port 3000, or rather that's the internal port, but the node port is on port like 31160, so that's the port number that we should use here to connect to this instance of the Juice shop. So this is a little reminder here that of the the goodness that the load balancer services give us, because as you can see, when we are using a node port, we can't use any port number we want, or well, you can use any port number you want as long as it's between 30,000 and 32,767. But if you want to use your own port number, including something like 80 or 443, then you have to use a load balancer service. Yes, we have some other ways to work around this, like we could use host network, we could use external IPs, but most often times we have to use a load balancer service. All right, so now we have this nice DNS integration in our cluster. So when we create services and later ingresses, we will be able to add automatically DNS records for these services and ingresses.